Hello everyone, hello, good evening. Can you guys hear me and see me? Let me know if I'm loud and clear. Can you see me clearly? Hello everyone. There was a small brief interruption. Yes, I couldn't see whether I'm live or not. So let me know if we can see me. Can you hear me loud and clear? Hello, yes, good evening, yes. So all of you can hear me and see me properly. Very good, guys. So this is Shreyas, your master teacher for physics at Vedantu, and today we are going to do, yes, a lot of problems, and we are also going to see the theory and brush up on all the important concepts of kinematics and projectile motion. Yes, let's do that. Welcome Satvik, Ankit, Venus, Tornado. Yes, Tornado is here. Hello Venu, hello Nancy, hello Vivek, Yalini, hello Praneeth, hello Harshit, hi my future, thank you for all the love. Hello Ankit, thank you for all the love. Hello Kartika, hello Venkata, hello. Welcome Vivek, welcome everyone out here. Hello Anurag, hello Shreyas Kapri, hi Shiva Kota. Good evening everyone. And by the way, I have been teaching for a very long time, not just at Vedantu, but even before joining Vedantu, I was associated with a lot of big names that you can think of in a lot of offline coaching industries. And then I moved to Vedantu because I want to reach out to thousands of kids out there, because when you are at offline, you are limited to a small group of students, and I want to make sure that every kid in India learns. And we started this channel with an aim where every kid out there in this country or beyond the borders who want to learn in English, they need to get proper guidance on how to study, how to make notes, what should be your timetable, what should be your patterns, what are the different strategies, and also learn all the topics. So that's why we are here at Enthuse. And if you want to know more about me, you can definitely follow me at Shreyas_Vedantu. That's my Instagram handle. Do that. And before we begin, do not forget to smash that like button and also hit the subscribe button, because only when you hit the subscribe button, you will be getting all the new videos, sessions, updates, posts, all the important stuff related to JEE and all the other competitive exams. And why do you need to like? Because guys, the only fees for attending the sessions over here, all right, at zero cost, is the cost of this like. That's it. All I'm asking is your love and support. That's it. Hello Anand Kumar, welcome. Yes, that's why we are here, for learning in English. Hello Khushi Patel, welcome. Hi Suvarna Minal Jagi, welcome. Hello Amu, hi Shrivani, hi Jaya, hi Nisha, hello everyone. And before we proceed ahead, I hope you remember that the next vote date is on 4th of April. That's hardly 2 days from now. So do not forget, vote is Vedantu Online Talent Examination, and you can register yourself for free. There are lots of exciting prizes to be won apart from the scholarship that you will get, which you can claim for registering at any of the courses. And if you're already registered in any of our pro subscription, crash courses, etc., you can get a refund of whatever scholarship money you get through vote examination. So it doesn't matter if you're enrolled or not enrolled, you can get a refund, or you can get that money back, whatever you win through this scholarship. And plus lots of daily prizes and V coins to be won, right from smartphones, smartwatches, Alexas, power bank, telescope, microscopes, and you name it. And also a chance to go to not to the moon, at least NASA, and a chance to become the CEO of Vedantu. So do not forget, you can check out our description box. There is a link for registering for vote for free, and download the app so that you can give the test this Sunday. All right, so let's begin with our class. And remember, you can also join our Telegram group. All right, Telegram group, where you will get all the PDFs of all the sessions, all the updates, and my beautiful voice notes out there. All right, so our Telegram group link is also there in the description box. Nice to see all of you out here. Hello Lini, good evening. Hello Harini, hello everyone. All right, so let's begin our class, guys. So Satvik, I have a good news for you. All the JEE 2022 aspirants, do you want to know when my first class with you guys is? Do you want to know when my first class with you guys is JEE 2022? I'm starting off with, guess what? Which topic am I starting off for? The 11th to 12th moving students. 11th to 12th moving students. Guys, yes, cheer up, buckle up. The 12th batch is starting this next week. Guess what? The date is on Tuesday. This Tuesday I'll be starting, Monday or Tuesday, yes. And all my classes now onwards will be at 9 o'clock. Keep this in mind. 9 o'clock, not 7 o'clock, 9 o'clock. And I'll be starting off with electrostatics. That's the first topic we are going to start with, and then we'll move on to the other topics. So get ready, guys. No, it will not be units and errors, Shiva. That's 11th standard topic, not a 12th standard topic. 11th to 12th moving batch. So for the 12th standard students, and for the 11th, or rather 10th to 11th moving batch, we'll be starting off things very soon. Don't worry. There will be some brush up sessions before your board exams, and after that we are going to have regular series as well. Don't worry. Yes. So Srinath, I think if you can afford 5,000, that extra 1,000 also you can afford, beta. And there are other options. You can pay via EMI also, Srinath. There are other options. My credit card and all those things are also there. So my advice is, if you can afford 5,000, somehow manage 1,000 rupees and just try it out. All right. Okay, cool. Let's begin. Now, average and instantaneous velocity. Now, remember, average velocity is displacement upon time. Now, what is this delta R? If you are wondering what is this delta R, well, this delta R is nothing but the change in position. So change in position is called delta R, which is nothing but displacement. Yes, this is nothing but displacement. Keep this in mind. So this is displacement, delta R. Change in position, final minus initial position. So delta R is nothing but final position minus initial position, that's displacement. So total displacement upon the time taken is average velocity. Similarly, yes, I'll be teaching electrostatics in detail. Remember, in Flash series, it was slightly confined or concise. It was not very elaborate, nor was it too small. Flash was somewhere between crash and one shot and the extensive lectures. Now we are going to start full-fledged lectures. All right, that's the batch we are going to start. Yes, I'll be teaching class 12 electrostatics complete, everything. Kushi, don't worry, we are there. Okay. Yes, okay. No problem, Srinath. And if possible, I would also love to help you out in different ways. All right, whenever you have any doubt, please ping me on my Instagram handle. Definitely we are there to help you out. Okay, now average acceleration, that is nothing but delta V. What is delta V over here? This delta V represents change in velocity. So change in velocity, which is nothing but final velocity minus initial velocity. Keep this in mind. Final velocity minus initial velocity is change in velocity. Change in velocity upon time gives you average acceleration. But when you have the displacement very small, time interval very small, that becomes instantaneous velocity, that is dx by dt or dr by dt. That's instantaneous velocity. Same way, instantaneous acceleration is dv by dt. Now, this will also give you some idea. If velocity is the derivative of position, I'll repeat. If velocity is the derivative of position, position is dash of velocity. I'll repeat. Velocity is derivative of position. R is position. So position is dash, fill in the blank, is dash of velocity. Come on guys, let me know in the chat box. Come on, let me know in the chat box. Come on, think about it. Is, yes, Andrew has already answered it. Very good. Position is dash of instantaneous velocity. Very good. Antiderivative. The other word for antiderivative given, Stacy, is integral. So the position, all right, is nothing but integral of velocity with respect to time. And if you don't have limits, you put a constant of integration. Same way, if acceleration, instantaneous acceleration is derivative of velocity. If acceleration is derivative of velocity, velocity is integral of acceleration with respect to time, and you can put a constant of integration. All right. Now, whenever you have motion along straight line with constant acceleration, this word is very important. Only when acceleration is constant in magnitude as well as direction, your three kinematic equations are obeyed. Number one, V is equal to U plus AT. That's the first one. V bar is U bar plus A bar T. Second one, S bar is U bar T plus half A bar T square. And the last one, V square is U square, or rather V square minus U square is 2A vector dot S vector. So those of you who do not know this, I'm telling you, it's actually a dot over here, but often we do not worry about the dot in 1D. We just use plus or minus over here because in 1D it's either cos 0 or cos 180, because that's how it is. Either they are parallel or anti-parallel. But if you want to use this in 2 dimension, this is what you need to do. It's A vector dot displacement vector. And remember, there is another equation, displacement in nth second, and that's U vector plus A vector divided by 2 into 2n minus 1. That's displacement in my nth second. Now what is nth second? So if I tell you displacement in 7th second, that means from 6 to 7, that's 7th second. If I tell you 8.3th second, 8.3th second, that is 7.3 to 8.3. That's the previous 1 second is called as the displacement in that previous 1 second. Thank you, Jibrat, for all the love from Kashmir. All my love for you, all of you. Thank you, Nisha, for all the love from Jharkhand as well. Yes, will all the chapters be covered, Srinath? Yes, all the chapters will be covered, Srinath. And yes, you can definitely post up your queries, your comments in the comment section after the video, and believe me, I will answer every bit, whatever you guys ask, and that's what I every time do. If you check out all my past videos, I have replied to each and every comment of yours. Everyone. Good evening, Sandhya. Good evening. Okay, now that you have written this down, these are the important formulas. Thank you, Mahesh Babu. Bandaru for all the love from Hyderabad. Snail, no problem. Just join in. Thank you, Angry Bird. Oh my God, we have angry birds, we have monkeys, we have goats. Guys, which animal is now remaining? Which animal is remaining? Okay, so time of flight, 2u sine theta by g. Second formula, maximum height, u square sine square theta by 2g. Alright, range formula, 2u square sine theta cos theta by g. You can also write this as, you can write 2 sine theta cos theta as sine 2 theta. Everybody knows that. Sine 2 theta. Okay, next up, equation of motion. The trajectory equation is y is x tan theta minus gx square by 2 u square cos square theta. Okay, so Snail, you just missed probably the starting part where I was talking about kinematics, velocity and acceleration. You can just rewind later on, but for now just follow whatever is happening live. Now you can also write it in another form. Now this is very useful. It is x tan theta. So y is also x tan theta, 1 minus x divided by range. Both equations are important and you must remember these equations. Alright. Hello Musel Mansuri. Thank you for coming. Nice to see your comments. I often see you on Instagram. Nice to see Musel. Musel is from Africa and he is a regular student of us and he's preparing for his examination which is going to write out there. Glad to see you live, Mosel. Very good. Yes. So what is the weightage of this chapter? Oh, by the way, Angry Gabbard, let me tell you, NTA recently conducted a survey of which was the chapter where students make most mistakes. And guess what? This is the chapter, Kinematics, Projectile Motion, Relative Motion, Vectors. The students make maximum mistakes in this chapter only. Yeah. All right. Yes, Mosel, no problem. You can just catch up at 2x speed. I hope, just like Shiva said for Snail, yes, you can catch up at 2x speed. And I've just started. This is just the second slide or third slide. Okay. So time of flight 2u sine theta by g, height u square sine square theta by 2g, range is 2 u square sine theta cos theta by g. You can also write this as, like I told, u square sine of 2 theta by g. This is using trigonometric formula. Sine 2 theta is 2 sine theta cos theta. Keep this in mind. And this is trajectory equation. It tells you, you tell me x, I will tell you y. As in, if you tell me where that particle is, it will tell me, this equation will tell me how high the particle is at any instant. So any value of x gives me any value of y. Now keep this in mind, at maximum height, speed is minimum. So speed is minimum, but it is not zero. Why is it not zero? The horizontal velocity is there. The x velocity is not zero. Only the y component disappears. You can see the red component disappears. It flips exactly at the highest point. The horizontal component always remains. In fact, this ux is always a constant, and the reason for it to be a constant is because the acceleration in the x direction is zero. There is no acceleration here, so there is no reason for the x velocity to change. So x velocity remains constant because there is no acceleration in x. The only acceleration which is there is only there in the y direction, and that's g, that's downwards. It's only there downwards. So only velocities will change in the y direction. So that's why you can see this red vector changes, whereas this blue horizontal vector remains constant. I hope this is clear. I hope this is clear. Yes, I'm not just kidding. Yes, this is what I told. Yeah, really, seriously, Snehal, Andrew, this is the chapter which many students committed mistakes. Yes. So Venkata and others, those of you who have a lot of doubts regarding how to study for coaching, this, YouTube, etc., please message me on Instagram or post up a comment after the video ends. Trust me, I'll answer all your doubts. Now let's just focus on the session. Next, formulas. Time of flight. When you throw a body from a height h, all right, when you throw it horizontally, all right, the time it takes, you throw a stone horizontally from a cliff, the time of flight is root of 2h by g is the same as just dropping a stone and falling like this. So when you throw it horizontally or you drop it, both of them are going to fall in the same time. Keep this in mind. So in fact, this is the projection. So when this stone is thrown horizontally and when you drop it, both of them will occur simultaneously in the vertical direction. All right. Velocity, well, that's u square plus root 2gh square. Actually, u is always going to be there and root 2gh is the vertical component. So the total velocity, that green arrow mark, see, the blue one is the horizontal velocity. The red one is root 2gh down. So the total vector sum will be this one. Okay. And the range will be the time into the horizontal speed. U is the horizontal speed and the time is basically root of 2h by g. So time into speed gives you distance traveled horizontally. As simple as that. I hope this is clear. Everyone understood? Everybody understood? Is this lecture enough for JEE in this chapter? Yes, AB Sheikh Abhi's music. Yes, it is enough. Oh, Ankit, am I not looking happy? Oh my God. Okay. No, I'm happy. Nothing like that. How time is same, Sandhya Rani? The thing is, see, when you drop something, all right, what is the velocity? Velocity is zero, right? In the y direction. When you throw something horizontally, what is the y velocity? It is still zero. Horizontally, yes. Vertical is still the same. What is the acceleration in the y direction? It's g. Correct? Same acceleration. What is the displacement in the y direction? Well, that's h. Don't you see, everything is same whether you drop it or whether you throw it. So it's like somebody just drew a projection. Oh, now it fell down. Acceleration is same in y direction for both of them. Velocity is same, displacement is same. Hence time is also same. I hope that's clear. Is that clear, Sandhya Rani? Alrighty, let's get going. Now this is one common doubt, guys. Please remember this, what I'm telling you. Every time people get confused. Sir, when to add velocities? When to subtract relative velocity? I never understand it. I know the formula, but I always get confused. How many minions get confused? Let me know in the chat box. Very nice, Ankit. Glad 9 PM is suitable for all of you. Alright. Yes, Satvik, obviously. Remember, did you not see the video I posted in front of the pool on April Fool's Day, Satvik? What are the 4 important things I told you? Watch that hardly 1 minute clip I posted. Hard work, dedication, self-study, all right, and the right teacher, the right guru. These are the 4 important things. All right, correct. Now let's see how to not get confused. Okay, now observe this. Now there are 2 things you should, or rather this is first thing that you should check for relative velocity is, are those velocities measured from the same perspective or different perspectives? What am I saying? Write it down, okay, in your notes. Are you seeing the 2 things from the same frame or from different frames? Okay, now let's say you're seeing it from the same frame. Example, I'm seeing a bus and a car sitting from a bus stop. I'm an observer and I'm seeing a car and a bus which are moving. So it's a same frame. But let's say I see a truck from a bus and then I see the same truck from a car. Those are 2 different frames. I sit in a car and then see the truck, and then I sit in a bus and then see the truck. So there are 2 different frames. I hope you get that. So that's all you need to check. So if you are in the same frame, keep this in mind. This formula works. What is this formula? This one. This formula, V12. For example, this one. This is for velocity of A with respect to B. Velocity of A with respect to B is velocity of A with respect to C minus velocity of B with respect to C. Look at that. The frame of reference is same. So this is, like you can see, same frame of reference. Same frame of reference. This is vector subtraction. Keep this in mind. Vector subtraction. Do you see that? Yes, this is vector subtraction. Questions are coming, Ankit. Remember, 0 to hero series is 2 things. One is theory. First part is theory. Next part of the 0 to hero series is only questions. So I'm just doing the theory. This is, I think, the last or second last slide of theory. Then we are coming to only questions. So get ready. Now, look at that. So velocity, all right, of A, the red car, with respect to C. That's what the first term says. Velocity of this car. I am on the yellow car. I am sitting in the yellow car. I am looking at the red car. That's the first term. I am sitting in the yellow car. All right, that is C. And looking at B. Who is B? The blue one. Sitting in yellow, I look at red and look at blue. I look at them and I see them having this velocity and this velocity. Is that clear? So then the relative velocity between both of them, the relative velocity between both of them is the subtraction of those 2 velocities vectorially. I hope now it is clear. I hope now it is clear. So this is what you should know. So for example, this velocity is, for example, it is 7 I cap. And let's say this velocity is 2 I cap. So what is the velocity of red car A with respect to the blue car? What is the velocity of the red car with respect to the blue car? It's red velocity minus the blue velocity. You can see that. So it will be nothing but red velocity. What is the red velocity? 2 I cap minus the blue velocity, which is 7 I cap. So that is going to give me minus 5 I cap. As simple as that. Yes. No, minus 5. Be careful. Be careful. Velocity of A is 2 minus velocity of B is 7 I cap. Okay, be careful. Yes, understood? Similarly, anything else? Say for example, this is 3 I cap and this car is going this way, let's say minus 4 I cap. Then what will you do? Again, velocity of A. What is velocity of A? It's minus 4 I cap. Minus velocity of B. What is it? Plus 3 I cap. So what are you going to get? What are you going to get? Yes, minus 7 I cap. Do you see this method is very simple? After this, you will never have a problem. Yes, after this, you will never have a problem. So if you are in the same frame, subtract the velocities. V12 is V1 minus V2. VAB is VA minus VB. V donkey monkey is V donkey minus V monkey. All understood, everyone? Velocity of Pandu with respect to Champa is velocity of Pandu minus velocity of Champa. That's how this works every time. Okay, very good, very good. Now, the problem happens when there are 2 different frames. So all that you need to do is shift this term over there. So guys, if this is VAC and this is VBC, just shift it over here. You will get VAB plus VBC is equal to VAC. This is what it is. So velocity of A with respect to B plus velocity of B with respect to C is velocity of A with respect to C. Do you see that there are two different frames? B frame and C frame. Look at that. B frame and C frame. So if I look at A with respect to B and then I look at B with respect to C, then A with respect to C is given by this formula. As simple as that. Okay, so basically you can see B is in between. So you guys have A, B, B, C. So forget that BB. Forget BB. BB matlab wife. Forget your wife. Alright, so A and C come together. Okay, understood everyone? This is the trick. This is the trick. Now I hope you will not get confused. Is that clear? Crystal clear? All the minions, let me know if you guys understood it. And if you understood it, go smash that like button down there. Go smash that like button down there. Glad Harshita. Yes. Coming to rain umbrella also. Done. Now, for rain umbrella problems, you know what you need to do? Only one thing. There is only one thing you need to remember. Equation. And that is this one. Guys, what did I tell you? How do you measure relative velocity? Well, you need to check whether you are in the same frame or different frame. Correct? That's all I told you. So, look over here. If I tell you velocity of rain is so and so, is it measured generally with respect to man or generally with respect to ground? If I tell you the velocity of rain is 7 kilometers per hour, making an angle 30 degrees with the vertical. If I tell you velocity of rain is 7 kilometers per hour, making 30 degrees angle with the vertical, which frame am I referring to? Ground or the person? Ground or the person? Think about it. Don't worry, Snehal, you will understand it now. Hold on, I am explaining. It's always with respect to ground. It's always with respect to ground, correct? So it's always, yeah, road, the ground, yes. Very good, Shiva. Very good, Gwen. Very good. Sandhya, you can find all my live lectures on this very channel, Enthuse. And all my previous lectures are also there in the playlist, which have been beautifully arranged in the past, in the playlist section out there. Now, when I say a person is moving with 10 kilometers per hour towards east, if I tell you a person is moving with 10 kilometers per hour towards east, where am I sitting and observing the person? Come on, answer the question in the chat box. A person is moving with 10 kilometers per hour towards east. Where am I sitting? I'm sitting on the ground frame. Correcto? Now, rain is measured with respect to ground. Person's velocity is also measured with respect to ground. So guys, are you going to subtract the velocities or are you going to use plus formula? Let me know in the chat box. If both the velocities, rain's velocity is measured with respect to ground, person's velocity is measured with respect to ground, are you going to subtract or are you going to add? Subtract. Remember, same frame, subtract. Different frames, add. Remember, that's the rule. I just told you, VAB, velocity of Pandu with respect to Champa is velocity of Pandu minus Champa. Velocity of donkey with respect to monkey is velocity of donkey minus velocity of monkey. Remember this. Subtraction. Correct. Now, when you are going to hold the umbrella, what matters? What matters? What matters is the velocity of how the rain is coming for the person. Doesn't matter how it comes with respect to the ground. It might come in any crazy way. I don't care. I don't give a damn. For me, the person, how is the rain falling? Is it falling flat on my face? Is it coming from behind? Accordingly, I'm going to hold my umbrella. So VRM, velocity of rain with respect to man matters. Correct. Velocity of rain with respect to man matters. Velocity of rain with respect to man. Think, what should you do? VRM. VRM means VR minus VM. That's it. Understood? So that's why this equation comes. Velocity of rain with respect to man. Keep this in mind. And how do you do this? It will be given to you. Oh, rain is falling in this direction. Man, that Pandu is moving in that direction. What do you do, guys? what do guys? Subtract. But when you subtract, which vector will you flip? Rain vector or VM vector? Obviously, where is that negative sign? In front of. It's in front of that man. So man's velocity will be flipped. So VR is here, man is going there, so minus VM will be here. Now forget this. I hope you guys understood. You will forget this and just draw the third side of the triangle that will give you velocity of the rain with respect to man. And that's the direction in which this Pandu is going to hold the umbrella, exactly like this. Exactly like this. I hope this is clear now. Yes. Why all students call me captive? Because they are all the sailors in the same ship or in the same plane. We are all having the same target. You are all my army and I am your captain leading the way to conquer, yes, the enemy. That's why I'm your captive. Alright, as JEE Mains. Cool, great. So if you guys have understood it, after this you'll never face a problem, okay? Last thing, boatman. Okay, let's do this. I hope you guys are having fun. At least I am having fun. Snehal, so the last part was very simple. Just repeat it once more. See, VR is here, VM is there. Because this equation says minus VM. So what are you going to flip? Velocity of man. So minus VM. So VR minus VM is VRM. Triangle law of vector addition. That's it. This is triangle law. A vector plus B vector is C vector. As simple as that. Remember, vector subtraction is actually vector addition. Just that you have to flip one vector because of that minus sign. That's it. Okay. Don't be tense, Ankit. Always learn in a peaceful, pleasant mind. Then you will learn more. Don't be in a hurry. Guys, chill out, relax. We are all having good fun. We are going to learn, all the concepts in a very pleasant manner. Yes, I know, Yalini, yes, I know that. Now, next thing, river boat man, okay? Keep this in mind, river boat man problems. Generally, if I tell you, the river is flowing towards east, with what am I talking? With respect to what am I talking? The river is flowing with 7 kilometers per hour towards the east. Generally, with what respect to am I talking? Come on, minions, answer the question. Harni, you can just replay back that same part again. I bet you will understand it. Very good, Shreyas. Very good, Priyal. Yes, Satvik. No, Satvik, not with respect to river. With respect to the ground, the banks of the river. If I tell you the river is flowing with so and so velocity, I am telling you the velocity of the river is 7 kilometers per hour with respect to ground, a person standing on the bank. Correct? Now, if I tell you a swimmer velocity or boat velocity, or a person can swim inside the river, a person's velocity in still water is 5 kilometers per hour, then is it with respect to the river or with respect to the ground? Carefully think and answer. Yes, I'm coming to that. Hold on, Snail. No, Jaya, we have not yet completed thermodynamics in 0 to hero. I'll be doing 0 to hero thermodynamics. If I tell you swimmer's velocity is so and so, is it with respect to river or is it with respect to ground? Answer this question, guys. It's always with respect to river. The river ke respect mein. With respect to river, how fast the swimmer can move. Because I don't care how fast the river moves, at least for now. If I tell you, I can swim in the river at 7 kilometers per hour. Now, please understand. You give me a river. You give me a lake, you give me an ocean, I don't care. For the water, with respect to the water, I will always end up swimming for that river, with respect to that river, with the same velocity. I hope that makes sense. So, if I'm in a lake, I'll swim at 7 kilometers per hour. And if the lake starts moving, I'll still swim with 7 kilometers per hour with respect to that lake, or with respect to that river, with respect to that moving water. So, my actual velocity will be different. I hope that makes sense. So still water, what do you mean by still water? A lot of people get confused. What is the meaning of still water? If I tell you the speed of the swimmer with respect to still water means what? When you see the water still, what is the velocity of the swimmer? Now, when do you think you are going to see the water still? When you yourself are the river. Doesn't it make sense? If you yourself are sitting or flowing with the river, basically the river frame of reference, then you will see the velocity of the swimmer. I hope that makes sense. Correct. Yes, Sachin, all the other questions, please post it in the comment section below or write to me on my Instagram. All right. Very good. Yes. Now, if this much is clear, Sachin, please don't spam bacha. Please post all your comments in the or all your questions in the comment section below after the video ends. Now let's focus on the session. Okay. So that's the meaning of still water. So U is the velocity of swimmer with respect to water. W is the velocity of the water with respect to ground. V is the total velocity of the swimmer with respect to ground. Do you see there are two frames of reference? Do you see there are two frames of reference? Now, whenever there are two frames of reference, what do you do, guys? What did I tell you? Subtract or add? Subtract or add? Subtract or add? Think about it. Come on. Yes. Harshita, if the river is flowing, basically that would be W. If the river velocity is given, that would be W. Add. Very good. Narani, the session started almost half an hour back. Very good. That's why you see addition over here. So, U is velocity of swimmer with respect to water, water with respect to ground. So you can see water gets cancelled, swimmer with respect to ground. Swimmer with respect to water plus water with respect to ground will be swimmer with respect to ground. I hope now it's clear. I hope this is fine. Everybody understood this? Now let's go to problems. And remember guys, all those of you who are interested in joining the pro subscription, the regular long-term batches at Vedantu, you guys can join in now because the batches are going to start very soon. Some of the batches have already started. Let me tell you that next batch is again going to start, and in pro subscription you not only get your regular batches but you also get test series, you get assignments till your advanced examination, yes, till the next year, and you will get the Tattva booklet hard copy couriered at your home. All right, the booklet which contains all the questions, assignments, derivations, theory, everything. Also best teachers obviously, and a choice to learn in English as well as Hindi. There are two separate batches. Okay, and lots of micro courses, crash courses, preparation for KVPY Olympiads. I'm going to teach in a lot of micro courses, and I'm also teaching in the toppers batch of 12th standard. So guys, if you don't want to miss this opportunity, please go ahead, click the link which is there in the description box below and use the coupon code SHHPRO to get a lightning deal. So instead of 48,600 rupees, you get 10% off for 1 year. Yes, 1 year. And that's 43,739 for the entire year. It includes doubts, test series, assignments, booklets, KVPY preparation, regular preparation, board preparation, micro courses. You can also learn from me in the paid platform. So all of this price is at least 1/3 of the regular price of any offline coaching institute that you can think of, where they don't even give you half the things that we are offering. Okay, so please check it out. And there is an easy EMI option by which you don't have to pay the entire amount. You can pay using monthly easy installments. So very small amount like 2,000-3,000 rupees you can pay, all right, depending on what you're selecting, and you can use this code so that you get additional 10% off. Yes, now let's begin with the question. Here comes the first question. Let's see how many of the minions can give this. Okay, come on minions. Ankit Jurawat, this is not a Hindi channel. There is a separate Hindi channel, bacha. You can go there. This is an English medium channel. Yes, Snehal, I do teach in the paid sessions as well. Okay, come on. A lot of you are saying B. Okay. No, I'm not going to give timer. It creates a lot of tension for a lot of students. Hi, Jeevan Reddy. Urushi saying B. Okay. Kirti Naran saying D. Priyal saying A. Come on, minions. Think carefully. Visham saying C. Satvik saying C. Okay. Hi, good evening, Satyendra. Join in, bacha log. Okay, I'll tell you what. The correct answer is actually D. Many of you got it wrong, I guess. Sanjay Kumar, yes, it is D. Yes, it is D. And I'll tell you why. Look at it. What kind of graph is it? Velocity versus time, right? Now, at B, where is B? B is over here. Okay, B is over here. Now think about it. Here, is the slope positive or negative from this point to this point? Is the slope positive or negative? Think about it. Is the slope positive or negative? It's down, right? So isn't it negative? Come on, think about it. Is it understood? Everybody getting it? Similarly, what is the slope in this part? Is the slope positive or negative from here to here? Is it positive or is it negative? Obviously, it is positive. Now, what does the slope of velocity time give you? What does the slope of velocity versus time give you? Think about it. What does the slope represent? Rate of change of velocity. What is rate of change of velocity? Oh, that's acceleration. So this slope is nothing else but acceleration. Correct? So this slope over here is also acceleration. So the acceleration has changed from negative to positive. Correct? Acceleration changed from negative to positive. Now what is force? Force is mass into acceleration. Force is ma. So if acceleration goes from negative to plus, the force also goes from negative to plus. Doesn't it make sense? So force also goes from minus to plus. Now if force goes from minus to plus, what does it mean? It has changed the direction. First it was this way, then it has gone that way. So that's why it has changed the direction. Is that now clear? Everybody understood this? Very good, Adi, Trishanku. Yes, acceleration, retardation. Yes, Andrew. Very good. No problems, Neil. Happens. Yes, yes. Very good, Satvik. Excellent. Let's get going to the next question coming up on your screen now. A particle moves in a plane, okay, with constant force. There is a constant force acting on it, having a direction which is different from that of the instantaneous velocity. A particle is moving in a plane where the force and velocity are not in the same direction. Then what is the path? Trajectory means path. What is the path taken by the particle? Is it a straight line, parabola, circle, or an ellipse? Come on, minions, this should be easy one. Come on. The force and velocity make an angle. Think of some example. Believe me, that will be easier for all of you. All right. Yes, some of you got it correct. And the answer is actually parabola. Now remember this. See, when gravity acts downwards, all right, and velocity is also there this way, what will that particle do? That particle's velocity keeps increasing and increasing. And what kind of path does it take? Obviously, it takes a straight line. Same way, if gravity is down and you throw the particle opposite to the force, all right, what does it do? It goes up and comes down. What kind of motion is this? This is still straight line motion, all right? This is still straight line. But if force is this way and velocity is like this, what kind of path does it take? This path is nothing but a parabola. And this is not just true for gravity and velocity. It's true for any constant force. So instead of mg, you have any force, but it should be constant. The path taken, all right, will always be a parabola. So that's something you should keep this in mind. Yes. Is that now clear? Understood how I have related to kinematics and projectile chapter? So whenever force is constant, what are the only two paths? Repeat with me, guys, in the chat box. If the force is constant, then what are the only two possible options for the particle's path? What are the only two possible paths for the particle? Think only two possible things which the particle can do when the force is constant. Only two things. Yes, Kirtaran. Parabola or straight line. Yes, straight line or parabola. Either of the two. But if the force makes an angle, then it has to be a parabola. If the force makes an angle like this, then it has to be a parabola. Else, if it is parallel or anti-parallel, it has to be a straight line. Very good. I hope you guys understood this simple logic. So many people don't know this and so many people are not taught all these things. So that's why I'm here in this Zero to Hero series, so that your concepts are clear and you can actually become a hero by the time you write the examinations. Okay, so a drunkard So a drunkard takes a step of 1 meter in 1 second. What does he do? He moves 1 meter every 1 second. Now he takes 5 seconds to move forward and 3 seconds to move backward. So he moves 5 meters forward, 3 meters backward. He is going like this. He's going like this. He's going like this. Right? He's going like this. Imagine he's going like this. He's going like this. He's a drunkard. He's going like this. And he's going back. I hope you guys got it. So there is a pit. There is a pit. After how many seconds is he going to fall in that pit? Think about it. Yes, think about it. Think about it. Think about it. After how much time is he going to fall inside the pit? Come on, you can think about it. What will happen if the force is perpendicular? Good. It's exactly like throwing a stone from a hill. It will still be a parabola. Yes. Okay, good. Yes. So Nivedita, at least a question from this chapter will come. At least one question. Okay, come on, think. After how many seconds is he going to fall inside the pit? Come on, minions. Come on. Waiting. Naveen Reddy says A. Shreyas Kapri says B. Not sure. Very easy. Thank you, Satyendra. So glad to hear that. Let's save him, Siva. Maybe not a good time to save him. Okay, some of you are saying A or B. Well, let's see how to do this. Okay, now he moves 5 meters forward and he effectively moves 3 meters backward. So actually how many meters has he moved? He has moved only 2 meters. And how much time does he take? 5 meters forward, 5 seconds. 3 meter backwards, more 3 seconds. He takes totally 8 seconds just to move 2 meters. 8 seconds he takes just to move 2 meters effectively. Correct. But don't do this. What's the distance between them? Well, that's 13 meters. This is 13 meters. So you might think, okay, let me see, 2, how many times does it come? Nah, you have to think just something little bit before falling inside the pit. Understand when he is 5 meters away. Why 5 meters? Because he moves 5 meters forward and backwards. When he's 5 meters away, just think about it. He's here. He moves 5 meters forward and then 3 meters backward. He won't get a chance to move 3 meters backward. Do you understand that? When he is actually how many meters ahead? He is 8 meters from his original position. That is, he is 5 meters away from the pit. He will move 5 meters ahead. But he won't get a chance to come back by 3 meters because he will be already inside the pit. So you need to be careful. So think about it. And think about it. How much time will he actually take to go from here to here? So from here to here, this 8 meters, how much time will he take? Answer in the chat box. Think about it. 8 meters. So every 2 meters is 8 seconds. So 8 meters, that is 4 times of 2 meters. So that is 8 multiplied by 4. That's 32 seconds, I believe. That's 32 seconds. Very good. Now what will happen, guys? Think about it. Now what will happen? Yes, now what will happen? 5 meters. The next 5 meters, how much time will it take? 5 seconds. So 32 seconds plus 5 seconds is how much seconds? It's 37 seconds. That's why the answer is C. Correcto. That's why the answer is C. Very good. Now you guys understood it. Excellent. So remember this, alcohol is injurious to health. Alright. So let's get moving to the next question. Beautiful question. A lot of people get it wrong. They answer either 31 or something else. Okay, next question. Beautiful question. When you throw two objects, object A and object B, object A is thrown up with some speed and object B is thrown down with the same speed. Object A goes up and comes down. Object B is thrown down, so it goes like this. Compare the final velocities just before hitting the ground. You're throwing both the stones with the same speed. One is up, one is down from the same point on the hill. One goes up and comes down, the other one just comes down. So when they hit the ground, which speed is more and whose time is more or less? Come on, think about it. Glad you enjoyed the question, Gwen. Okay, Snehal 8 into 4 because each 2 meters takes 8 seconds. Each 2 meters will take 8 seconds, and like that he has to do it 4 times. 2 meters, 2 meters, 2 meters, 2 meters. So 8 seconds, 8 seconds, 8 seconds, 8 seconds. So that's why 8 into 4. Okay, a lot of people are saying A, some of you are saying C and D as well. Interesting. Let's see what should be the correct answer. Come on, minions. Come on, come on, come on. Okay, let's see what should be the answer. See, guys. Okay. Now, if you throw a stone with some speed u, it goes up and it comes over here. What speed will it have over here when it comes to the same point? If I throw a stone up, by the time it comes back to the same point, what speed will it have? Won't it be the same? Won't it be u only? Correct? And after that, its speed will increase, 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 and it will hit the ground with some velocity. Let's say VA. VA is the velocity. Correct? Now, imagine you throw another stone, but downwards with the same speed u. What will it do? It will do the same thing what this stone did after this point of time. If you throw it down with speed u, it's doing the same thing. So it's going to go down and it's going to hit the ground with the same speed. So VA and VB both have to be equal. Yes, so VA will be equal to VB. But what about the time? Obviously, A has traveled more distance, B has traveled less distance. So B's time will be less and A's time will be more. Hence, option will be C. Understood, guys, why the C option will be correct? Very good, very good. Yes, that's the option which is correct. Very good, excellent, minions. Let's get going to the next one. Okay, very good, very good. I'm so happy you guys are understanding it, and if you guys are having fun, come on, let me know and go smash that like button out there. And if you're new to the channel, go smash that subscribe button. Okay, now a particle starts from the origin, from rest, and it is accelerating uniformly. Read the words carefully. Which graphs are correct for position, for acceleration, for velocity? Come on, think about it. Very good. Come on, come on, come on. Think, 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 think. Which of the following graphs are correct if a particle starts from rest, from the origin, with uniform acceleration? Come on, think about it. Should not be so difficult. Come on, minions, you can do this. Okay, D, D, B. All right, all right. Come on, minions, think, think, think about it. Well, well, well. I think, yes, D is correct. Very good. Raksha, Santosh, Nancy, Vinny, Snehal. Yes, Vyasham, yes. Harshita got it wrong, no problem. All right, Kirtharan. Very good, very good, very good. Yalini, very good. Yes, the correct answer is D, because acceleration is constant. So look at that, constant acceleration. Do you see that? Acceleration is constant. If acceleration is constant, velocity will increase at a constant rate. And if velocity increases, position will be a parabolic graph. This will be a parabolic graph. It will, every time its velocity is increasing. So that's why the graph should be from origin and it should keep on increasing. So because velocity is increasing, the slope should increase. Hence A, B and D. As simple as that. Okay. This was the easy one. Let's do this. Let's see how many of you can do this very easily. There's a person, he travels on a straight road now such that half the distance he travels with V1 and the remaining half distance he travels with other speed V2. What is the average velocity for the entire duration? What is the average velocity for the entire duration? Come on, minions, let's see how many of you get this. Okay, looks like Snehal knows the answer already. Come on, Vishim also knows the answer. Vinny also knows the answer, looks like it. Wow, very good Sanjay, very good Yalini, looks like it. So it's very simple. So let's say he travels d by 2 distance with speed v1 and the remaining d by 2 distance with speed v2. So the total average speed will be total distance. What is the total distance? Okay, let me make this d and d, that will be better. D and this is d. It will be d plus d, correct? D distance plus d distance is total distance by total time, t1 plus t2. Why times are different? Because speeds are different. Now this will become 2d divided by, what is time t1? Time to go from here to here. Time is distance by speed. Time t2, again distance divided by speed. Now what will happen next? D cancels. So it will become 2 divided by 1 by v1 plus 1 by v2. Now what will you do next? Take LCM. So it will become 2 divided by v2 plus v1 divided by v1 v2. Now shift v1 v2 on the other side, on the top. So it will be 2 v1 v2 divided by v1 plus v2, which is option D. That's the answer. Very good. Yes. So that's the answer. That's how you do it. And if there are more distances, you can do it accordingly. So you should know the derivation. Don't just mug up the formulas. Okay. Chalo. Let's see the next question. And here it is. Bullet question. A bullet of mass 20 grams has initial speed of 1 meter per second. Just before it enters a wall, alright, whose thickness is 20 centimeter, alright, that's the velocity which is given, 1 meter per second. Now, if the wall offers a resistive force, now what will a force do? Retard it. So, by the time it comes outside, it will have a lesser speed than 1 meter per second. So, which of the following is the correct speed? Come on, think about it. Come on, minions, think. Think. Come on, minions, think. Girish, good night. I hope you'll see the remaining part of the lecture later on. Come on, yes, come on, minions. My God, I need to really install something in my room. I'm sweating a lot, but it's okay. Option C. No, I don't think so. Think again. Properly calculate it. You need to calculate it. It's not a straightforward question. So there is retardation because of which the speed is going to reduce. First figure out what is the retardation, and then after that use some kinematic equation, and from that you are going to get the new speed. Come on, minions, you can do this. Yes, hi Srinivas, this is a JEE channel. Whatever we do in this channel will be useful for JEE. Well, I'll tell you what. First, since the force is given, using this, F is equal to mass into acceleration. So acceleration will be force divided by mass. So what is the force? Force is 2.5 into 10 to the power minus 2. And what is the mass? 20 grams. So 20 grams, that is 20 into 10 to the power minus 3. So that's going to make it, alright, I can make it as 25 into 10 to the power, or 2.5, I can write it as 5 by 2. And this I can write it as 2 into 10 to the power minus 3, and this is 10 to the power minus 2, this is 10 to the power minus 2. So 10 to the power minus 2, 10 to the power minus 2 goes, so this will become 5 by 4 meters per second square. This is the retardation. This acceleration is negative, but I have just figured out the magnitude. So this is just the magnitude of the acceleration, just think about it. Okay, so the acceleration is so and so. Now just use which equation? V square is u square plus 2 into acceleration multiplied by displacement. Just use that. So therefore V square will be, what is u? It is 1. What is acceleration? Well, that's 5 by 4. And what's the displacement? That's, I think, 20 centimeter. That's 0.2 meters. So 0.2 meters is nothing but 2 divided by 10. Correct. Now this 2 and this 2 will go with this 4. This 5 will go with this 10 as 2. And this is retardation. So I need to put a minus sign because it's retarding. So it will be 1 minus half, which is half. But that is V square. So V will be 1 by root 2. Now what is 1 by root 2? That's 0.707. So approximately that's 0.7 meters per second. Yes, I have put minus. Yes, I have put minus. Yes, I hope that's clear. Everybody understood this? Everybody understood? No, the calculation is not that bad. So you should know the value of root 2 and 1 by root 2. Root 2 value is 1.414. 1 by root 2 is 0.707. You should know those values. Very good, minions. Let's get going. I hope you guys are understanding slowly how to do these problems. Okay, next question. Beautiful question. If you have seen fountains and if you love fountains, you should be able to solve this problem, guys. Water fountain on the ground sprinkles water everywhere around it. If the speed of water coming out from the fountain is V, what is the maximum area that can be covered? which will get wet. What's the maximum area? The word maximum is not there. The word maximum is not there, but just understand what is the maximum area that will get wet if the speed is v. Come on, let's see how many of you get this. Yes, Sai, why not? If you try hard, if you do self-study, if you attend all the classes, and if you are sincere, dedicated, trust me, you will get, obviously. Yes, Sai Srinivas, why not? You will. Gitendra, don't demotivate students. Don't do that. Not good. Come on, come on, come on, come on. A lot of you are saying A. Come on, come on, come on, come on. Let's see. I don't know. I don't know. Is it A or something else? Hello, Shrasti Shetty. Welcome. Join in. Yes, correct. Good. Some of you are saying B. Yes, one question always comes from in JEE from this chapter. And NTA, like I told by analysis that most of the students make a mistake from this chapter only. I don't know why. So guys, understand the range, the maximum range, the max range will decide the maximum area that can get wet. So what's the value of R max? Well, that's U square. In this case, it's V square sine 2 times of 45 degree, that's when the range is maximum, divided by G, which is going to make it V square by G. Now the area, that area will be pi times range max, which will be the radius square. So that's going to be pi V square by G whole square. That's going to give me the answer as option A. Is that correct? Very good, very good. No problem, Kala Murugan. Don't worry. Even if you don't understand 20, 30, 50% of it, it's okay. You understood 50%? No problem. Watch the lecture again, because you have to work hard. You have to watch things again and again. And maybe the second time, third time, you'll understand it. And what is important that you understand, see how to solve problems, how to apply formulas. And even if you get 5 more questions, 6 more questions just by attending my series over here, trust me, there will be no other person happier than me. I'll be really happy. And trust me, this has happened. In fact, one student, and not just one, many students message, sir, I got 20 percentile, now I got 70 percentile. Sir, I had got 50 percentile, sir, now I'm getting 85 percentile. Sir, I had got 90 percentile, now I'm getting 97 percentile. So are you seeing the differences in the percentiles? So that's what happens. So just have faith in me. This is going to work out for you as well. Okay, chalo, let's get going. That correct answer was option A. Yes, yes, Marvel's Avengers, definitely attend my 0 to Hero series, and from next week I'm starting JEE 2022 series. We'll also do revision bit of 11th standard, don't worry about it. Alright, and my flash series are also recorded and kept, so you can also brush up through all the 11th standard topics as well. Here is the next question coming up on your screen. Oh my god, JEE Mains, thank you so much. I'm so cute. Okay. Okay. A body is projected at 30 degrees with horizontal. Okay. The air offers resistance. Usually air resistance is not there. And it is proportional to velocity. Okay. Which of the following is correct? Come on, read the options and think about it. Very good, Marvel Avengers. If you have seen everything and if you have practiced problems, trust me, you're already one step ahead. Now just practice the problems, keep 1 or 2 days for revision, and rest of the days just attend our classes or join the pro subscription so that you are in a regular long-term batch. Okay. Hello Akshaya, welcome, join in. A lot of you are saying A, Kirtan saying C. No, only one option is correct, Ankit. 2 options are not correct. Only one option is correct. Well, guess what? The correct answer is actually C. Yes. See, when there is no resistance, the path will be like this. And what is that path? It's a parabola. The best part about a parabola, well, it's symmetric. Whatever is there on the left is there on the right. Whatever happens while going up will happen while going down. But when there is air resistance, it's not going to be a parabola. It's going to lose a lot of velocity. And it is going to fall something like this. It's going to fall like this. It's not even going to be symmetric. It's not going to be symmetric. Time taken to go up, don't go down. No, it's not going to be same, because while going up it had different speed. While coming down it will have different speed, because it's already retarded. Already the speed has come down. A lot of energy is sucked away. So energy is not conserved. So the resistance force is a non-conservative force. It will suck away the energy. Energy is not conserved. It is not symmetric. So the only correct answer will be C, because at the topmost point, obviously the velocity will be horizontal. So velocity will be horizontal at the topmost point. That's it. Correct. Okay. Wow, Laksh, क्या बात है, पुरानी यादें ताज़ा हो गई. Yes, very good. Okay, so Sanket, for graphical questions, I would say start using Desmos a little bit and try to make a lot of equations and see how the graphs work. And whenever we do graphical questions, just see how we do it. Mainly, you should be very good with derivatives and integration and curve plotting. Derivatives, integration and curve plotting. Once you are adept, once you are skillful in these three topics, trust me, automatically you become efficient in solving graphical questions in chemistry, physics, maths. Okay. Yes. Come on, let's get going to the next one. So Sanjay Kumar, which part you did not understand? So for the last part, even when there is a resistance, there will be one point when the velocity will be horizontal. That's it. So there is one point, even when there is a resistance, the velocity is horizontal, vertical component will be 0. That's when it's at the maximum height. I hope now it's clear, Sanjay. Okay, for the rest other things, remember air resistance is non-conservative, it will suck away the energy. So kinetic plus potential won't be constant, as simple as that. Okay, great. Some of them are PYQs, some of them are not. Some of them are my own questions, some of them are from some different books. Okay, don't worry, Jugal. I'll take a lot of questions from graphs in thermodynamics as well. Okay, come on, let's do this. Okay, guys, this is very easy. Look at that, a projectile, all right, a projectile is projected with some kinetic energy K, and what is given? The range is R, correct? The range is R. Now, the range is R. It will have minimum kinetic energy. Where will the kinetic energy be minimum? Here, right? K is minimum. And where is that? Where is that? How much is this distance? Obviously, it's R by 2, which is 0.5 R. Isn't it obvious? Isn't it obvious? Is it now clear? Very good, Sanjay. Very good, Jugal. Great. So that's how it is. 0.5 R. Excellent. B. Very good, Amru. Next question. Beautiful question. Let's see how many of you can do this. Yes, Satvik, I'll be covering all the concepts, obviously, of 2020 in the series of 12th standard. Definitely. Even in flash series, I covered as much as possible. So now in the 12th standard series also we'll be doing all the concepts, don't worry. Okay, let's see. There is a person standing here. The sound is emitted by an aeroplane. It comes from this side, but by the time the sound reaches and it is heard, the person sees the aeroplane directly above him. So the sound is emitted here, the sound travels like this, but by the time the plane has moved here, just when the sound reaches. The question is, what's the velocity of the plane? Come on, that's the question. If v is the speed of sound, what is the velocity of the plane? Come on, let's see. Doing this, how many of you are able to get the answer? Very interesting question. In 2 lines maximum you will get the answer. Maximum 2 lines. Just draw the diagram. Come on, come on, come on, come on, minions. You can do this. You can definitely do this. Come on, minions. Okay. Yes, Vijay Kumar, I finished almost all the syllabus of 11th and 12th in my flash series. Yes, I did that because a lot of people needed it. That was important. A lot of you are seeing A and D. Okay, I'll tell you what. Okay, cool, cool. Keep posting your answers. I'll solve it meanwhile. So I'll just draw a line like this. I'll just draw a line like this. And I'll just draw a line like this. Now the sound is going to travel via this path. Sound is going to take this path. The plane is obviously going to take that path. Now, my thing is, the sound from here to here and the plane from here to here both take the same time. The sound when emitted from the plane and the plane to reach here will take the same time. But their speeds are different. So let's say the speed of the plane, alright, is u. And the speed of the sound is given to be v. And it's already mentioned that it's coming at an angle of 60 degrees with the ground level. So this angle is 60 degrees. So think about it, this angle will be 30 degrees. Correct? This angle is 30 degrees. So this upon this, if this is a right angle triangle, this upon this is sine 30. All right, so sine 30 is, this is nothing but distance traveled by the plane, and this is nothing but distance traveled by the sound. I hope you can see that. Pythagoras, trigonometry, as simple as that. Guys, now what is the distance by the plane? Speed into time. What is the distance by the sound? Velocity into time. T goes. Sine 30 is half. So what is u? U is v by 2, and that's going to be option D. I hope that's fine. Okay. So Shreyas, the prerequisites for electrostatics is basics of gravity. Gravity, vectors. Yeah, gravity, vectors, work, power, energy. You should know gravity, vectors, work, power, energy, and NLM. You should know these 4 chapters for electrostatics. All right, very good, minions. The answer is D. Let's get moving to the boat river problem. A boat is sent across a river with a velocity of 8 kilometers per hour. Okay, the boat is sent with 8 kilometers per hour. If the net velocity ends up being 10 because the river is flowing, what is the actual velocity of the river? Remember, the boat is sent across. Think, what does this word across mean? What does this word across mean? It means something. So think about it, then solve the problem, you will get the answer. It's sent across. Come on, minions, think about it. Come on, think. Come on, minions. What is the correct answer? Some of you are saying B. All right. Okay. Interesting. Come on, minions. Well, I'll tell you what. Okay. Boat is sent across. Across means perpendicular to the banks. Perpendicular to the banks and perpendicular to the flow of the river. Perpendicular to the flow of the river. Now, where is the river flowing? The river is flowing like this. The river is flowing like this. The boat is sent like this. The boat is sent like this. With what speed? 8 kilometers per hour. What is the river velocity? I don't know. Let's assume it to be W. The resultant velocity, the resultant of both of them, comes out to be 10. Now, isn't this Pythagoras at the end of the day? So 10 square is 8 square plus W square. So what is W square? Come on, it's 6 square. So W is 6. And that's the answer. 6 kilometers per hour. I understood? Yes. I think, yeah, Ansh, I'm a fan too. I have seen a lot of his lectures. I've seen a lot of his quotes and a lot of his small interviews and all that. Yes, I do like Feynman, the way he approaches physics with minimal mathematics. That's nice. Okay, so that's the answer, guys. Let's get moving to the next question, relative velocity question. Okay, come on, get ready, guys. A car starts from rest and it's 200 meters behind a bus. Often it happens. There is a school bus. Maybe somebody forgot something and the car is running after the school bus. Now, both of them are at rest. The two start with the same, they start at the same instant, but different acceleration. The bus has slower acceleration, 2 meters per second square. The car has 4 meters per second square. So after how much time will the car reach the bus? After how much time will the car reach the bus? That's the question. Let's see how to do this. Can't we use VRM is VR minus VM? Gwen, that's for rain, man. This is boat problem. For boat, it is velocity of boat plus velocity of river is the net velocity. Remember that. That's different. Don't get confused. Thank you, SG guys. Now, how to do this problem? See, guys, both of them start from rest. All right. So let's draw the situation first. So this is at rest. This is at rest. Acha. Now the bus moves something. The bus moves something. Okay. And the car also moves something. Okay. But when I look at it from the ground frame, I find it to be a little bit difficult. I feel it's better we sit on the car or sit on the bus. That will make things easier. Remember, the bus has an acceleration of 2 meters per second square and the car has an acceleration of 4 meters per second square. Cool? Now, where do you want to sit? I think let's sit on the bus. That's going to be a little bit convenient, I guess. So I'm going to sit on the bus frame of reference. So my frame of reference is bus. So my frame of reference is bus. Now think about it. What I'm going to do is use everything relatively. All kinematic equations, everything relatively. Okay. What is velocity of the car with respect to bus? Remember, what did I tell you? U12 is U1 minus U2. U Pandu Champa is U Pandu minus Champa. U donkey with respect to monkey is U donkey minus U monkey. Alright, so use that. So it will be UC minus UB. Hey, but guess what? Both of them are at rest. So 0 minus 0 is 0 initially. Correct. Yes, Ansh, I do know Paul sir and he teaches really well. Yes, he's a very great exceptional teacher. Yes. Next up. And now what I'm going to do? ACB. ACB, same way, AC minus AB, correct? So what is AC? Acceleration of the car? Well, that's 4. Can you see that? Car's acceleration is 4. Acceleration of the bus, that's 2. So what am I going to get? 2 meters per second square. Everybody got this? Now, last thing, displacement of car with respect to bus. Tell me this part. Come on, quickly tell me what is this answer. Very good, Ankita, you have already found out the answer. Very good, but I'm showing you the method. So it's okay. Very good. You got the answer really fast. Oh my God. So attend both, or maybe you can keep one lecture later on. I know a lot of lectures might clash at many times, but both are great teachers. You should attend both the classes. You can keep one as an option. You can watch the other one later on. All right, as a recorded one. Okay, so guys, the displacement of the car with respect to the bus. Think about it. You are the bus. You see the car 200 meters behind you initially. All right, the car is 200 meters behind you. Just visualize, you are looking there, the car is 200 meters behind you. Slowly it catches up. How much has it moved with respect to the bus which you are sitting in? You are the bus, the car is 200 meters behind you and it eventually catches up. So with respect to the bus, how much has it moved? Let me know in the chat box. Let me know in the chat box. How much has it actually moved? Think about it. You are the bus, car is 200 meters behind, the car catches up and meets the bus. How much has it actually moved? Very good, very good, very good. It has moved 200 meters. Correct. Now the only thing left, the final nail in the coffin is S is ut plus half at square. S is ut plus half at square. Just use this and you'll get the answer. So 200 is u is 0 plus half into acceleration. Well, that's 2 into time. I don't know. 2 gone. So t is square root of 200, which is 10 root 2. That's the answer. Understood? Madhuri, I have already done 0 to hero of electrostatics, I guess. Just watch the lecture. All right. So please watch that 0 to hero series on electrostatics. It's there in the 0 to hero playlist. Just check it out on this very own channel. Okay. So, oops, what the hell? Okay. Yeah. Next question coming up on your screen is this one. The last question for today. Are you guys ready for the last question of today? Yes, Madhuri, I have already done that. Very good, guys. You guys are understanding a lot. Brilliant. And guys, do you like this 9 p.m. slot? Very good. Thank you, Harshita. Guys, every day I'm going to come now at 9 o'clock. My timings have been changed. 7 o'clock, I have now a batch in the regular paid version, all right, of Vedantu. So I'm taking classes on the Vedantu platform as well. For those of you who do not know. So I have my classes. So the timings are going to clash. So I thought, why not take the classes at 9 o'clock? Anyways, you would have had your dinner and plus you will be free from any other commitments. I know some of the classes might coincide with maybe some other channels which you are following, but try to attend the classes out here as well live. All right, cool. So if you are revising this chapter, but I'm starting this chapter, Vijay Kumar, if you're starting this chapter, then I would say Flash series. But Zero to Hero is a good starting point to get an idea. But if you want to go in depth, then please watch Flash series also after this. Okay, Zero to Hero timing will be just this one. And guys, I'm also going to throw a poll on Telegram for morning sessions. I'm starting morning sessions also. Are you guys ready? Are you going to show me some support in the morning? What say, guys? Are you going to show me some support in the morning? I'm waiting for it. And meanwhile, you can also start solving the question. Come on, think about it. Hi, Kanak Sharma. Yes, Kanak Sharma, you are quite late. At which time? Yes, I'm going to throw a poll. Which time is suitable? Most likely 8 o'clock or something. Yes, before 8 a.m. Yeah, don't worry. I'm going to throw a poll. Yes, very good, very good. I want to see that, Josh, because you have to wake up early. You have to work hard. And I conducted a class on why you should wake up early and how it's beneficial for your health and what are the different things you should do to wake up early. So yes, I'm going to conduct at least 2 days classes in the morning as well. All right. So guys, yes, don't worry about it. Cool. Let's get moving to the next question. Let's see how to do this. Interesting question. Okay. 5 o'clock. Oh my God. Yes. Let's do that. Okay. So how to do this? Well, see, the engine crosses the pole with speed u. Now, by the time the last compartment comes over here, the speed has increased to v. So think about it. Which equation can I use? V square is u square plus 2as. This is the length of the train. So initially, the speed of the last bogie was u, but by the time it reaches here, the speed becomes v. So I'll use v square is u square plus 2al. Therefore, 2a is v square minus u square by l. That's one equation. Now for the second part. The middle compartment, alright, by the time it reaches here, alright, it will have some speed, let's say w. The middle compartment, by the time it reaches here, it has speed w. So what do I do? Again, w square. Before that, it would have the same speed. Remember, the entire train was moving with u speed. Slowly the speed is increasing. The train was moving with speed u. Alright. Then after some time, the speed becomes w, somewhere in between. It will be u square plus 2a. At this time, displacement will be l by 2. Be careful. That's it. Now substitute the value of 2a from here over here. So it's going to be u square plus v square minus u square by l into l by 2. Now l goes and you're going to get u square plus v square by 2 minus u square by 2. So that's going to give me u square minus u square by 2 is u square by 2. So u square by 2 plus v square by 2, that's w square. So w will be root of that. So that's going to be this. Is that clear, everyone? So Mahashakti, where will I be teaching in English or Hindi? Where? On this channel, I'll be always teaching in English, and in the regular batches also I teach in English. Okay? But I'm comfortable with both. On some channels, I often come in Hindi as well. Okay, very good. That's the answer. Do you guys love this session? Yeah, already. Very good. Okay, there is this one question out here. Oh, I didn't realize there was one more question, guys. Yes, one more question. Yes. Thank you, Vijay Kumar. Thank you. Now, this last question. There is a ball projected. I will show you a beautiful, mind-blowing shortcut way of solving this problem. It goes like this. This is 4 meters. This is 4 meters. This h, I don't know. And this is 6 meters. The question is, what is the height of the wall if this is, I think, 45 degrees? Yeah, this is 45 degrees. And you are throwing it with some speed. You know how to solve this problem? Use this equation. Y is x tan theta 1 minus x by r. Just use this. What is x? X is 4. X coordinate, that's 4. Tan 45. 1 minus x is 4. And range, well, that's 4 plus 6, that's 10. That's it. Tan tan 45, that's 1. And 1 minus 4 by 10, well, that's going to be 6 by 10. Now that's 24 by 10, which is 2.4 meters. That's the height, because y coordinate will be the height. Think about it. That's the answer. I hope this is clear. That's it. As simple as that. That's the answer. So you saw the application of trajectory equation over here. It's going to be so easy if you use that equation. Else you will just be puzzled with all different equations and you wouldn't know how to solve them. So you should know the right equations at the right time. And those of you who want to prepare for the April and the May attempt and who want test series and all the 11th and 12th standard revision in this short time, along with assignments, along with live classes, along with morning to night doubt solving, along with in-class doubt solving, along with tests, mock tests, 20 of them, and also discussions after every test, and also a batch in English. Yes, an English batch crash course for all of you in the evening every day. Please visit the link which is there in the description box below. Join using that link and you will also get additional 4,000 rupees. That's 40% off if you use the coupon code SHCC. The crash course is starting 5th April. That's this Monday. Very limited seats. And if you miss this opportunity, I don't know when again the crash course is going to start. So please join the crash course. Ramki, don't worry, the goodies are going to come. Guys, it's taking longer than usual. I've just got sorted with the goodies. I'm going to take some time to pack the hoodies and the goodies. Hold on, like I said, you will get it after 2 to 3 weeks. You're not going to get it immediately. Okay, so hold on, don't worry. Okay, chalo guys. So please join the crash course, and if you have loved and enjoyed this session, please support and love us by smashing the like button. And do not forget, if you're a new student, you have to subscribe for free of cost, and we'll be there always for you, and you will not miss a session. And if you love this session, do a favor, just as a Guru Dakshina, share this video with all your friends and all your cousins who might need these kind of sessions. Thank you very much for being here. See you again every day at 9 o'clock. Most likely you will see me here at 9 o'clock, and any other changes you will always find it on Telegram or in the upcoming live streams on this channel. Bye bye. Have a great night. Take care.